Good day, my dear students. How are you today? I hope you have already read all the 3 ebooks. Not necessarily you finished reading them, but at least you must have read several pages. Today, I am going to discuss with you how to understand what we see over there in the sky. What are those things? Why are those things behave that way? But before we can answer those questions, we need to familiarize our location in relation to the objects there. First, let me draw the observer. It could be you. Okay, it could be you. The observer is somewhere here. Okay? There. Then, so, I could be that observer. I would be looking my location down. So, I'm located here. This is my immediate location. Then, from here, I go, or I put my sight further. From here, then, then then until the farthest point, somewhere here, the farthest point. Beyond that point, I cannot see anything anymore. Okay? And then, I look at the sky. Let's say, my location, okay, is the Silliman ground, particularly the amphitheater of Silliman University. I hope you are familiar with our amphitheater. The amphitheater is the ground surrounded with acacia trees. And from the east, you have the sea. From the west, you have the mountain. From the east, okay, east, somewhere there, okay, you have the sea somewhere here. You can see the blue water, sea water. And of course, you have here the administration building. You have here the administration building. The business and finance building. Somewhere here. The business and finance building. Where you are going to pay. And then this is the west. No, I'm sorry. If this is the west, this is the east. Okay, east. Okay. So this is the east. Okay, east. East, where the sun rises, is the east. Where the sun sets is the west. So, here, west, you have, my dear students, you have here the Seliman Church. Okay? You have the Seliman Church here. Okay. Seliman Church. And behind Seliman Church are the mountains. Okay? Are the mountains. Behind Seliman Church are the mountains. The Seliman Church is facing the sea. The sea. Okay. So, your location is right on the amphitheater. You look up the sky. Okay. So, you look up the sky. You look up the sky. Here. Let's see. The sky. Then, on the sky, okay, on the sky, you have the bright objects, the stars, okay? Stars, 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 shining, sparkling stars, okay? Shining stars, sparkling stars. This one, this is what we call the dome. It's just like a roof, dome, roof. On the roof, on the dome, you have the stars and all objects like the planets and the asteroids. Here. So, you have here the dome. You have here the dome. If we extend further, if we are located on an open, wide farmland, okay, the ground where we are located, the ground where we are located, the ground where we are located, the ground and the dome meet. The dome kisses the ground. The ground kisses the dome. Where the dome and the ground meets, we call that the horizon. Okay? So this is the horizon here. You have here the horizon. Horizon. Horizon here. Where the sky meets the ground, that point where there is the meeting of the sky and the ground, we call that the horizon. Okay. So, the point directly above you, the point directly above you, this point directly above you, this point, this is what we call the zenith. Zenith. Okay? And the distance, okay, from the horizon up, this is the declination. Declination. Again, the distance from the horizon to a point or to a star. So you want to have the distance of the star here. What is the angle of this star? Or what is the location of this star? We can point the distance in terms of declination, in terms of angle. In terms of angle. So, one complete, okay? Of course, if you are going to the other side of the planet, the other side, okay? There you are, one complete path around is 360 degrees. Half of the 360 degrees is 180. Half of the circle is 180. Okay. Now, suppose this star is, let us say, the declination is 18 degrees. Meaning to say, 18 degrees is what? If this is 180 degrees, 180, of course, the other side is 180, 360. If this is the 180, because what we see is only the 180, okay, degrees, on the assumption that we are standing on an open, wide field. No obstruction, no buildings, no mountains. Wide open over there. You see over there, wide open. No obstruction. No buildings, no mountains, no trees. Wide open. So what you see is only 180 degrees. When you say 18 degrees, that 18 degrees is 1/10. 18 degrees, 18 degrees equals 1/10 of the sky, you see. 1/10 of the sky, and 1/10 of the sky is 180 degrees. This is the sky, okay? This is the sky, or we call the dome. This is the dome, which is only 1/2. Because the total, okay? The total line here, total path, the entire dome would be a circular one. We only have half of the sky. We see only half of the sky. So half of the sky means 180 degrees. So 18 degrees is just 1/10 of 180 degrees. So, we are going to locate distances, okay, by means of degrees. Now, if only the sky, its space would be just like the space of a bond paper, a pad paper, we will be using only the protractor. Or if you want a straight line, the ruler. But we cannot do that if you are going to measure the objects. They're up there, over there, somewhere there, very far. We cannot go there, bring a ruler or a protractor. So what shall we do to measure the distances between stars? How far is one star from the other star? We go to what we call the heavenly twin constellation. The winter constellation we call the Gemini. The Gemini. How far are the two twin stars from each other? So, they are very far. How far is Pollux to the other twin? One of the stars in Gemini is Pollux. How far? We cannot go there and bring a protractor. So what shall we do? We will be using our hand. Whack! As wide as possible. This is 25 degrees. From each other. There's another star, 25 degrees. Okay, use this one, huh? The thumb and the pinky. The thumb and the pinky. Suppose shorter than 25 degrees, because this 25 degrees, use this one. The index finger and the pinky. This is 15 degrees. Okay. Next to 15 degrees, 10 degrees. From this knuckle to this knuckle, this is 10 degrees. Next to 10 degrees, this one. From this end to this end, this is 5 degrees. Then, this one, this is 1 degree. To appreciate 1 degree distance, you just imagine that the moon is 0.5 degree. This is 1 degree, the moon is 0.5. So, you only need half of your pinky to cover the moon. The full moon, The full moon. You want to cover the full moon? Just half of your pinky finger. Cover the full moon. Because the full moon has a length of only 0.5 degree. And this pinky finger has a width of about 1 degree. So that is how we are going to measure distances using our hand. Okay. Now, so these are stars. Now, and some books, if not some, many books would call this one the celestial sphere. This is the celestial sphere. One half of the celestial sphere is the dome we are considering. This is the celestial sphere. Okay, so on the surface of the celestial sphere, you have here the stars. The old hypothesis, one of the hypotheses, of course, already discarded by the most recent one. That hypothesis tells us that all the stars are just right on the surface of the sphere, the celestial sphere. If you have a small star, that star is small. If you have a big star, that star is a big star. And why they are moving because the celestial sphere moves. The earth is fixed. This hypothesis is supporting the geocentric theory. The doctrine of geocentricity is telling us that the earth is stationary. All objects, including the sun, revolve around the earth. And one of those that revolve around the earth, this celestial sphere. The stars are moving because the celestial sphere moves. This is the east, this is the west, okay? The sun rises from the east, sits at the west. So, you see the sun, if this is the sun here, somewhere here, at the horizon east, okay? It moves higher, high noon. Lower, sets in the evening. So the sun is rising. So the celestial sphere is moving that way. Why this one is moving that way? Because according to the heliocentric theory, which is now the correct theory, the one supported by all experiments, that the earth is the one moving, tells us that the earth moves counterclockwise. The earth is moving counterclockwise. The sun is stationary here. Okay? Stars are stationary, but when the earth moves counterclockwise, earth moves counterclockwise, everything moves clockwise. The sun rises. The moon rises. Okay? Because they move opposite to the direction of motion of the earth. Okay. The theory about the celestial sphere, as I told you, already discarded, but this can still be useful, okay, to appreciate the locations of the objects in the sky. But just that, as to the accurate distances, how far one star from the other star, we have to remove the concept of celestial sphere. If the star is small, it does not mean that it is small. It is small because it is very, very far. Very far. So you see that star smaller because the star is located at very, very far distance. While the other star looks bigger because it is nearer. That is one. Possibilities. So when we study astronomy, we need to have what we call distances in terms of astronomical units. In terms of light years, because they are very, very far. And so, you have there patterns of stars. We call constellations here. So they are observing. And so, there comes what we call astrology. And people are still practicing astrology. Astrology is not astronomy. Astrology is trying to connect human life, human behavior, human future with the location, position of the stars, particularly of the constellations. In astrology, we say that, well, constellation Gemini, sometimes called the heavenly twins, the winter constellations, because they appear whole night of December, January. You can see whole night of December days and January days until February days. Right there, up there in the horizon, Gemini. But in astrology, that is the birth star of those who were born May. Gemini does not appear May. Okay? They are winter constellations. Winter constellations, meaning to say, they appear very clearly, very brightly during December, January, and until February. During that time, the Gemini constellation is being blocked. The sun now is blocking. So, if you have here, going to erase this one, erase. You have here the sun. This is the sun. You have here the earth. Earth. Okay? Nighttime, daytime is caused by the rotation of the earth. The nighttime and daytime happens because of the rotation of the earth, not because of its motion around the sun. not because it is moving around the sun. When this one is this part of the earth facing the sun, this is daytime. This is daytime, facing the sun. And therefore, this is nighttime. Half of the earth, approximately half of the earth is nighttime. Nighttime is when that part of the earth is not facing the sun. Daytime is when that part of the earth is facing the sun. And because our earth rotates, and you are assigned to compute for the rotation of every planet, including the earth, one complete rotation of the earth on its axis is about 24 hours. And what is the speed to rotate on its axis? The axis here referred to is the south-north axis, because it has an axis. If this is the earth, if we draw a line, this is south and this is north. Okay? So, the earth rotates on its axis counterclockwise. The rotation of the earth on its axis is the one that causes daytime and nighttime. So this one facing the sun, daytime. The other one, the other side, nighttime. Where is Gemini? Constellation Gemini is here. Gemini. It's something like that. There are 3 stars. Actually, there are 4 stars. That is how it looks. Okay? So, this is June. June. This one is December. So, during daytime, you cannot see Gemini. During nighttime here, you cannot see also Gemini here because Gemini is not located here. Gemini is not located here. What is located here is another constellation. Okay, so during nighttime, you cannot see Gemini. Remember that people here, during nighttime, here on this side, will see the sky with stars. Of course, we can still see the sky during daytime, but we cannot clearly see the stars during daytime because of the brightness of the sun. The brightness of the sun versus the brightness of the stars and the planets is much, much higher and greater, stronger. So the brightness of the sun covers all the brightness of the stars and planets. So we can see stars, planets during nighttime. Very clear because there is the absence of the sun. And the best night to look at the stars, to look at the planets, the best night is that night with cloudless sky and moonless night. Moonless. So moonless night, new moon. There is no moon. So when there is no moon and it is cloudless, you can see so many stars. You can even see the what we call the galactic dust. Galactic dust, the one being observed by people in somewhere in the Darwin Nahandi. What this? So there are the galactic dust of Milky Way. We'll be discussing about galactic dust. So this is the situation. Okay? So we'll be discussing more about this. Meanwhile, you have to read the ebooks I sent to you because there you can find the explanation as to the difference between astrology and astronomy, the difference between cosmology and astronomy. What is the difference between cosmology and astronomy? It's in the ebook. Okay? Okay? Bye. Bye.